Hello, dear students. Hope you all are fine. In the last session, we discussed different formula of integration, side by side the derivatives. We all know that integration is a process reverse to the differentiation. So today, based upon the integral formula, we solve some problems. Let us see one by one. Okay. Let's take one example. Number 1, integration of 1 plus x whole cube divided by root x dx. How can we solve this problem? How can we find the solution of this problem? Dear students, in integration, one thing is very important. That is, the function which are given to us, we want to bring them in the integrable form. I repeat, in integrable form. That means here this function, I want to bring it in integrable form. So dear students, we can apply 1 plus x whole cube. That means a plus b whole cube formula over it. And then we can bring it to the integrable form. Look here how we can do it. Simply I keep this integration sign. Now a plus b whole cube, that means a cube plus 3a square b, then 3ab square, and finally the b cube, and divided by root of x. I keep this within a bracket and I keep the differentiation elements here out of the bracket. Now I can divide this, throw out this by root x. So it will become integration of 1 by root x dx plus 3x by root x dx plus 3x square by root x dx plus x cube, integration of x cube by root x dx. Look here, as there are plus sign, so I distribute the integral sign over every terms. That means now if I integrate it, that means this root x I can take in the numerator, and it can be written as root x. It can be written as x power minus 1 by 2 dx. Similarly, I can take these 3 out of this integration sign, and this x by root x, that it can also be written as this way, dx, plus 3 can be taken out, and here what we have, x power 3 by 2 dx, and here we have, that is x power, that is after dividing it we will get x power 5 by 2 dx. Okay dear students, am I clear to you? Now here what I did, I simply expand the a plus b whole cube and bring the function in the integrable form, and that will be the main target of doing integration. You have to bring the given function to the integrable form only by using, sometimes by using identities, sometimes by using trigonometry formula, sometimes by using rationalizing, sometimes just adding plus or minus in the numerator. So likewise, so many ways you have to follow in the coming questions. Now look here, that is x power minus 1 by 2. I have to integrate it, that is x power n form. That is x power n form is, integration of x power n form is x n plus 1 by n plus 1 plus c. That means after doing integration here, what we can do, that is x power 1 by 2 plus 1 by minus 1 by 2 plus 1. Here is, we can put c1 here. Likewise, 3 is as it is as constant out of this integration sign, and here I put x power 1 by 2 plus 1 divided by plus C2 plus 3 x power 3 power 2 plus 1 by 3 by 2 plus 1 plus C3 x power 5 by 2 plus 1 by 5 by 2 plus 1 plus C4. Now look here. Now if I add this power and the denominator become that is equal to x power 1 upon 2 by 1 by 2 plus 3 x power 3 by 2 by 3 by 2 plus 3 times of x power 5 by 2 by 5 by 2 and finally that is x power 7 by 2 by 7 by 2 and I add all the constants and give as a sum capital C. Now after simplifying this term, all these terms, what we can get the final result? That our final result will be 2 times of x power 1 by 2 and these three cancel, again 2 power of x power 3 by 2 and here it will be 6 by 5 x power of 5 by 2 and this is 2 by 7 x power of 5 by 2 plus C. So this is the final answer. Dear student, you have seen that how I expand the question and then after I perform the integration over it. Likewise, every question demands its own solution. You cannot proceed in a single way. You have to think over it. Thinking is most important here in this lesson. Your idea, how can we make the given integral in the integrable form? How can I make the given question in integrable form? That is the integration. Our known form, I want to bring it in our known form. And how we can make it? That is the process. Okay, look at this problem. X square plus cos square x divided by 1 plus x square multiplied with cosec square x. So this problem, how we can solve? Just we take one step here. Integration of x square plus cos square x we can write as 1 minus sin square x divided by 1 plus x square and here is cosec x square x dx. Now if I make the separate terms from here, look here what happened. This is x square plus 1 by 1 upon x square minus sin square x upon 1 plus x square full multiplied with cosec square x and dx. This part x square plus 1 or 1 plus x square, this part we can cancel. Obviously we have simply 1 here and minus sin square x by 1 plus x square multiplied with cosec square x dx. When we multiplied this cosec square x in the interior of this bracket, what happened? That is become cosec square x dx minus simply we will remain with 1 upon 1 plus x square and dx. Now you can see here cosec square x we know is minus of cot x plus c and integration of dx upon 1 plus x square is tan inverse of x plus c. That means simply you can replace these two terms, these two integrations by these two forms So our final answer will be, cosec square x. Cosec square x we can write minus of cot x minus of tan inverse of x plus c. So this is the final answer of this question. Okay, dear student. Now we proceed to the one more type of questions. Let's see this type of problem. Dx upon 1 plus sin x. Here what we can do? Nothing, simply we can rationalize it. That is dx upon 1 plus sin x. Rationalizing, that means 1 minus sin x divided by 1 minus of sin x, and dx is here. So this is integration of 1 minus of sin x by cos square x dx, a plus b into a minus b form. That is 1 minus sin square x, that is cos square x. 1 minus sin square x equal to cos square x. That form I have used here. That is integration of 1 upon cos square x dx and minus integration of sin x by cos x, that is tan x and sec x dx. So this is equal to 1 upon cos square x, that is integration of sec square x, whose integration is known to us. Similarly, integration of sec x tan x, that integration also known to us. So our final answer will be our sec square x, that means this is tan x. Here is one minus sign, so I keep minus, and sec x tan x, that is integration of sec x plus c. So that is the answer of this question. This is the final answer. This is the final answer of this question. So dear students, in every question you can do some different way. You have to think over it, how can I bring the given function or given question in the non-integrable form. Non-integrable form, once you can bring it, that is means your integration is over. Now look here at this question. This is integration of sine power 8 minus cos power 8 divided by 1 minus 2 sine square x cos square x dx. It is another type of problem. How we can simplify and get the integrable form. Let's see. Simply you can apply a square minus b square form, and you can get, that is integration of sine power 4x minus sine power cos power 4x into sine power 4x plus cos power 4x full divided by 1 minus 2 sine square x cos square x, and dx is here. A plus b, a minus b. How? Because this sine power 4, sine power 8 can be written as like this, can be written as sine power 4 whole square minus cos power 4 x the whole square. That means a square minus b square. I have applied here a minus b into a plus b form. Again, here in this part we also apply this a plus b, a square minus b square form. So we'll get here, that is sine square x minus cos square x sine square x plus cos square x into this part is as it is, sine power 4x plus cos power 4x full divided by 1 minus 2 sine square x cos square x and dx. Now as we know, that is cos square x minus sine square x equal to cos 2x equal to cos, but we have here sine square x minus cos square x, so we can take minus cos 2x as minus cos 2x. So this is minus sign. I can keep this minus sign out of this integration, and we can write this part as cos 2x. Minus sign I keep outside. And sin square x plus cos square x is 1, you all know, that is this part will vanish, and simply we remain with sin power 4 x plus cos power 4 x full divided by 1 minus 2 sin square x cos square x. Now here we can do some more simplification. I can write this part as minus integration of cos 2x, and this part can be written as sin square x plus cos square x the whole square. I keep here one more bracket, and minus of 2 sin square x cos square x. I close the bracket here, and out of all of this we have dx. So this part a plus b whole square, that a square b square plus 2ab, and that plus 2ab we have to minus subtract it, that's why minus 2 sin square x cos square x, and full divided by 1 minus 2 sin square x and cos square x. Now look here, this sin square x plus cos square x, this part is 1 again. So what we have now? We have minus cos 2x, and this part is here. This is sin square x plus cos square x, so 1 square means 1, minus 2 sin square x cos square x, bracket close, full divided by 1 minus 2 sin square x cos square x, and dx. Now see this part, numerator and denominator both are same, so we can cancel it. Ultimately we have cos 2x and dx. So cos 2x and dx, as we know, integration of cos 2x is sin 2x by 2 plus c, that is minus. Here, as we all know, integration of cos x dx is equals to sin x plus c. That form we have used, and these two, remember these two, cos 2x, remember the derivative rules, chain rule. There what we did, sin 2x, derivative of sin 2x, what we did there, cos 2x, and for this 2x we put 2 here. Same thing in integration also, the cos 2x, the integration of cos 2x is sin 2x, and for this 2x we put 2 in the denominator. As we know, the integration process is reverse, so we have to divide it. Here in chain rule we multiply, so here we have to divide. Otherwise we have one more way to explain this, that is substitution way, that we discuss in the next part. So this is the final answer of this question. So likewise you can do so many questions, you have to practice. Integration is only for practice. You can be a perfect one in integration after doing lot of practice of different types of problems. I have shown here some different types of problems and how we have to simplify them, how we have to we can come to the integrable form, that I have shown. These types of problems you can practice a lot, and then only you become master on it. Let's go to the next part. These problems we have solved, no need any foundation, no need any particular formula. We can go in different ways, but there are some problems which we can solve very easily by using some distinct methods of integration. Method of integration. Number 1 is substitution method. Substitution. Number 2 is partial fraction. Number 3 is integration by parts. These are the 3 methods that we have to study here in your syllabus. Let's start with substitution method. Substitution means we have to replace the variable to some other variable. Let's see how it is happening. Let's take an example. Suppose I have the integration of sine 2x plus 3 dx in this form. So what we can do for it? We can assume this is as a new variable t. 2x plus 3 as t. That means 2x plus 3 as t. Now I differentiate this one with respect to x. So that means this implies, that is, when I differentiate this with respect to x, we have 2 here equal to dt by dx. So this implies dx is nothing, dx equals to 1 by 2 dt. Now I replace this integration I by this one and this one. Let's see how. This is I and integration of sine as it is. This is, I have written t, and this dx become 1 by 2 dt. So 1 by 2 I am writing here and here is dt. Now look here, I have substituted, that is 2x plus 3 by this t, and change complete function. I change in new variable t, that is t and dt. There is no the old variable x. Now it is in integrable form. My sine, integration of sine t, that we all know, that is integration of sine t is minus of cos t plus c. Now I was given with, this is 2x plus 3. I done the integration with the new variable. So I have to replace this new variable by our original one. So here is the final answer, that is minus 2 cos, and this t is what? 2x plus 3, and we have c. This is the final answer of this type of questions. So simply we replace some part of a function by a new variable, and then after I make it in the integrable form and done the integration. After that finally I substitute the original variable and we get the result. Like way you can make the substitution and you do the integration. Some more type of this integration, and that is the most important. Suppose in a function we have given a function as I equal to some function as f of x, f of g of x, and g dash of x dx. That means a function is in this form, f of g of x, and with that derivative of that function, derivative of g also exists in this function. If I can find such a function, then the integration is most easy one. I simply put this g as t, then I find the derivative of this t, and we get this one. Then our total integrand will change to a new variable and it become a integrable form. Let's see one example. Look at this problem. Now if I put this cos x as t, then dt will be minus of sin x dx. So now therefore this I become minus, I keep here, sin x dx, for that I put dt, and this cos that is replaced by t square. So now here I can integrate it because I know the integration formula of t power n. So t power n, that means minus t power 3 divided by 3 plus c. So this is the integration of this t square. Now we have to replace this is by cos x because our original variable is cos x. So that means I equal to minus cos cube x divided by 3 plus c. That is the answer. So this way we can do these questions. Okay, dear students, in the last section, in the last class, we have derived so many formula of integrations, and we seen that there we use derivative formula and their corresponding integrations. But in some questions, in some formula, you might have noticed that we never got the integration of tan x dx, cot x dx, sec x dx, and cosec x dx. We got the derivative of these things, but there was no integration of this tan x, cot x, sec x, cosec x. So I have to derive this integration of tan x, sec x, cot x and cosec x by using substitution method. I show you one, and remaining will be your own task. Let me take tan x, integration of tan x dx. So tan x can be written as sin x by cos x. Put t equal to cos x, that is dt become minus of sin x dx. So therefore I become integration of minus, and this is sin x dx become dt by t, and that is nothing but minus of log t plus c. Now minus of this is equal to minus of log mod, that is t means what? T is your cos x plus c. So this one you can use as the formula of this one, that is integration of tan x. Integration of tan x can we use as minus of log cos x. We can derive little more and we can get the one more formula for it, that is log of cos x, this minus sign go as per law in the power, and that will give you log of 1 by cos x plus c, and this is log of sec x plus c. That means integration of tan x, we can use this form also, we can use this formula, or we can use this formula. Both of these can be used as the formula for the integration of tan x. I show you integration of sec x. The cot x, integration of cot x and tan x are same. Only you have to write, that is sin x by cos x. Instead of writing sin x by cos x, you have to write cos x by sin x, and then substitute t as sin x, and you will get the result. Whereas for sec x, I show you the integration of sec x, and you will do the integration of cosec x of your own. Let's see, that is integration of sec x dx. We simply multiply and divide this sec x by sec x plus tan x divided by sec x plus tan x and dx. If we multiply, you will get sec square x plus sec x tan x, and dx is here, dx, and this is full divided by sec x plus tan x. Now we have to substitute this one as t. Let's see. Let's see, let t equal to, that is sec x plus tan x, that is dt equal to sec x tan x, that is sec x tan x, and tan x is sec square x, and with this you must get dx. So we can replace this part. Now look here, we can replace this part by this dt, and this part already we assumed as t. So ultimately we have I equal to dt upon t, that is nothing but of log t plus c, and that is equal to log of sec x plus tan x, and that is plus c. That is the final, or you can say the formula of sec x. Likewise you will get the integration of cosec x, and that is also used as a standard formula. So with this substitution we can get the standard formula for tan x, cot x, sec x and cosec x as well. Okay dear student, I think you have enjoyed this lesson, and you can practice, you start practicing, and only practicing make you perfect in this lesson. Different formula, different questions, different ideas are needed in this solution of this problem. Okay, hope you stay safe and be in home and enjoy your lesson. Thank you.